Today we had a long day. In fact, most of you have also woken up early in the morning at 7 o'clock where we had an amazing zero to hero session. And tonight we are going to complete electrostatics in this 5th lecture. And then we'll start with Gauss's law. But yes, before going ahead, we are also going to have a Menti quiz. So those of you who are new and probably have missed few of the classes, do not forget to check out our playlist, and you all are going to battle it out in the Menti quiz on electrostatics, which would be conducted next week. How many of you are ready? Let me know in the chat box. I can read all your chats. How many of you warriors are ready to fight the battle out? Come on, my minions. You have to become warriors. Come on, we enthusiasts. How many of you are ready? How many of you are going to fight it out in the Menti? And in case you have missed any of the classes, you can check out the playlist. So let's get going with the final class on field lines and equipotential surfaces with me, Shreyas. And before that, do not forget to check out the details of the vote, which is going to be conducted this Sunday. And that's the Vedantu Online Talent Examination for getting amazing scholarships. So, welcome aboard, guys. We are going to talk about field and equipotential lines. Look at this lovely diagram. It's so amazing, right? So we're going to talk more about this and a lot of amazing things. I know that's a dipole. We have completed dipole, in fact, in our previous class. All right, Kirti Haran says yes. Kirti Haran is going to be a warrior. Very good. Soundarya Heli is also going to be a warrior. Yes, Shreyas Gabriel, I'm very good. Oh my god, Munab is asking me to grow a full beard. I doubt it, but let's see. Yes, Vikram is going to rock it. Yes, Amu is also ready. Okay, very good, very good, very good, John. Very good. All right, I take it as a compliment. I look very young. My voice is also very young, and I hope I remain young for a long time. All right, thank you, Gains Music. Thank you so much. Thank you. Hello, Andrew. Welcome aboard. Hi, Swati. How many of you are new warriors out here to win for Enthuse channel? Yeah, if you are a new warrior, let me know, and also introduce yourself to all the other fellow people out here. Make new friends. Yes, grow the family, make this family large, and make sure you help each other out. And guys, if you want to know more about me, then do not forget, you can also check me out on my Instagram handle. That's Shreyas_Vedantu. All right, John is a new warrior. Wow, good. Yep, after my lectures, DC Pandey plus PYQ, is it enough for mains? Yes, definitely. Very good. Let's fight it out, guys. And before we begin, do not forget to smash that like button down there. Yes, please smash it because it means a lot for me. And if you are a new warrior, do not forget to hit the subscribe button. Just click on it so that you do not miss any of our regular updates. Now, those of you who are wondering, what is this Pathfinder series? Pathfinder is a series for 11th to 12th moving JEE 2022 aspirants or even NEET 2022 aspirants. So all the aspirants who are going to write different competitive examinations like JEE, NEET, BITSAT, boards in year 2022. This is a long-term series meant for you guys, and slowly and steadily we are going to complete all the portions of the 12th standard in a very detailed manner. Also, we are going to have lots of Menti quizzes. So if you are 11th to 12th moving 2022 aspirant, please do not forget to hit the subscribe button because it is going to be really beneficial for you. And as we near the end and you're going to write the examinations, we're going to have a lot of mock test series and lot of informative lectures out here. Yes, let's begin our class as well. Welcome, Neha. Hello, everyone. Hello, hi Bharat. Good evening, Shivangi. All right, so your captain is ready to go. Get set, go. So let's begin. And before we go ahead, let me tell you, it's a long way ahead, and looks like it that you guys are going to stay at home and you're going to learn from home. So guys, YouTube lectures are always going to be there for all of you. You can study sitting at home, don't have to travel anywhere. You cannot obviously put yourself at risk by traveling outside or visiting a coaching class out there. Now, I want you to really appreciate, the benefits of online learning by just sitting at home. And it's not just YouTube. You can get lots of assignments. You can prepare for tests. You can see your report cards in a very detailed manner. See guys, when you write your tests in a regular offline coaching institute, you cannot do an analysis because you only get the final score, and whatever you remember might be vague, it might not be precise because there is no data. But in Vedantu, when you write your tests, there is a detailed analysis because you are writing it on a computer. So at the back end, the machine learning algorithms can check out how much time are you spending on each question. They can also check your projected scores. They can also check what kind of mistakes are you making. They give you a detailed report card of how you can manage time, and at the end we also have something like benchmark tests which help you out with what should be the next steps, and all these are fully automated. And I can keep on naming all the benefits that you can get, but remember, we do have long-term batches which are starting in Vedantu for 11th to 12th moving. Some of them have already started, so it's a long way to go for all of you. So the long-term batches have started, and I'm teaching in many of the micro courses. I'm also teaching in the topper batch, and there are many good teachers out here who are doing amazing job. Plus, there is a doubt app where you can ask all your doubts, and there are regular tests just like your long-term course, and you will also be getting courses for preparing for KVPY examination, board examination, and any other examination that you can think of. So it's a 1-year full-term plan. So guys, do not forget to check out the description link below, because the course is only for 43,739 for the whole year, and there are easy EMI options also which are available. Do not forget to check it out. Use the coupon code SHHPRO if you want to avail the discount. Alright, so now let's begin with our class. Welcome aboard. Looks like we have a good strength now. Hello, Krishnammohan Sigarbord Thala, welcome. Hello, good evening, good evening, good evening. Yes, so the mentee is not tomorrow, Ankit, the mentee is going to be next week. Yes, the mentee is going to be next week. Yep. Okay, now first thing, what is a field line? Now field line is basically an imaginary concept. Any charge around you creates field. Any charge around you creates field. Okay, and we have seen that. And the value of the field was defined as the force per unit charge, if you remember that. It's the value of the force per unit charge. Now, let's say you are at this point. The field is, let's say, in this direction. You travel in that direction. When you travel in that direction, let's say the force is in that direction, the blue arrow mark. At that new point, the force might be in some other direction. So again, you travel in that particular direction and you move a little bit in that particular direction. Now at that new point, the force on a charge, a test charge, might be in a new direction. So you keep on traveling. The curve that will be traced is called as a field line. So the curve that will be traced is called as a field line. So what is a field line? It's an imaginary concept. And how do you draw a field line? You place an imaginary test charge and then see what is the direction of the force. Travel in the direction of the force little bit and see what is the new direction of the force. Travel in that new direction and again travel in that new direction of the force. You will keep on traveling along a curve or maybe a straight line depending on the situation. That curve which is traced is called as a field line. Okay. Hello Himanshi. Hi Vikram. Welcome aboard. So Munava, yes, this is the last lecture of electrostatics. Next is a mentee quiz. Yes. Hi Katcharan. Welcome aboard. Hi Vinu. Thank you so much for all the love from Kerala. Okay, so having said that, now let's look at some field lines due to some geometry. So it's going to be very interesting. Hi Anish, good evening. Hi Nancy, good evening. Yes, okay. Now, don't worry, electrostatics is not going to miss you because it is going to keep on coming. Even in the mains exam, mock tests and so many other examinations, trust me on that. See, if you take a positive charge, the field lines will come outwards like this. Why? Because if you take, or if you stand over here, okay, let's say you stand over here, if you place a charge, a test charge, what will be the direction of the field? The direction of the field will be in this direction. Now if you go in this direction here, obviously again if you place a charge over here, the direction of the field will be like this. Again if you go over here and place a test charge, the direction of the field will be like this. So a positive charge, the field lines will come out from the positive charge symmetrically distributed in all the directions. You can see that for a positive charge, the field lines are symmetrically distributed in all the directions and they are originating from the positive charge. But if you take a negative charge like I have shown over here, and if you place a positive test charge, the direction of the field will be like this. And if you go over here and again put a positive charge, again the direction of the force or the field will be like this. So the field lines are inwards. So you can clearly see in this case it is inwards, alright, it is inwards, and in this case it is outwards. You can clearly see that. I hope this is clear. Very interesting. Now there are a few more things that I want you to see. Few more things that you want to see. Alright. The thing is, Himanshi, NEET is not postponed, that is NEET post-graduation, so don't get confused. NEET is not postponed, so don't spread rumors, be careful. I think you read it wrong. It's post-graduation, it's not for you, it's not for 12th moving students, okay? Okay, cool. Now, understand that when you are close enough to the charge in this region, alright, isn't the field very, very strong? Isn't the field very strong? And when you are far away in this region, it is weak. So you can see that. So all these are some interesting things that you can note down, and I'll be discussing all the pointers in detail now. So for now, you have seen the field lines due to a positive and a negative charge. The field lines will start from a positive charge, they end or terminate on a negative charge, and this is how it looks like. Now, this is the first property that you should be writing it down. Yes, in fact, I have shown you this diagram. What is this called, guys? Come on, type it out in the chat box. What do you think? Yes, is this system called? Yes, we're going to see, Anish, different kind of systems, like what if you place a negative, positive, or two positives, one positive, one negative, etc. Yeah, we're going to see all of that. Yes, they radially terminate and originate. Excellent, Shivangi, Manki, Andrew, Muna, Bhai, Shreyas, Priyanka, Neha. Hey, oh, yes. Yeah. No problem, Himanshi, happens, you know, sometimes you get scared looking at the thumbnail only. Oh my god, what is this? Oh my god, this is scary. Oh, something has changed. So that's why at Enthuse, we never create, you know, unnecessary hype. We do not give you rumors. We do not tell you, hey, you know what? JEE might get postponed. And if I do a video on that, trust me, I'll get a lot of views and a lot of likes and a lot of crowd will come, because I'll be doing a nice rumor mongering video because, oh, is JEE going to be postponed? But we do not do that. We believe in facts. If something is going to happen, if we get to know from trusted sources, if something is actually happening, only then we tell it to you. We do not unnecessarily brainwash kids out there. I know a lot of channels do that. We do not do that. Okay, yes, this is a dipole, guys, and dipole is nothing but a positive and a negative charge. Looks like many of you warriors were already present in the previous lecture. So you can see from the positive charge, the field lines originate and they always terminate on a negative charge. This is one of the most important properties which you should write down. All right, so do not forget this. And remember one thing, there is one more option possible. See, you can see the field lines originating from positive, and yes, you can also see the field lines terminating at negative charge, but there is another option. See, for just a positive charge, the field lines, where do they terminate? Where do the field lines terminate just for a single positive charge? They terminate at infinity. So that is also an option. Understand, the field lines can either terminate at negative charge or they can end at infinity. Now when I say they end at infinity, do not think of it like this. Oh, I need to travel light years outside our solar system, outside our galaxy, and then I will reach a boundary wall, and that would be called infinite. And then there will be a person waiting for you, and he'll be like, welcome, you have reached to infinity. And then that's where the field lines are going to end. Sorry, that's not what infinity is. Infinity means it's a polite way of saying never, or it's not going to. I hope this is clear. Yes, I hope this is clear. Is that understood, guys? Is that understood? So basically the field lines never end. That's a polite way. Yeah. That's what is going to happen. Cool. Same thing is also true for negative charge. The field lines originate from infinity. They originate from infinity like this. What does it mean? Can you read some place where they will be like, again, welcome, you know, this is where our journey begins. welcome aboard. No, that's not what is going to happen. It's going to start from somewhere. You can never reach there. Understand that. Yes, to infinity and beyond. Oh, this is a tagline from which movie? A very famous movie, guys. Let me know in case you remember which movie this is from. Yep, cool. Okay, yes, so some of you got confused for a second. Interesting. Okay, cool. Let's get going for the next property. And the next property, yes, Toy Story. How many of you have watched it? It's one of my favorite. I've seen all the parts. I love it, guys. I mean, so emotionally connecting movies. I mean, you can literally reimagine your childhood and you can actually feel for those toys out there. It's such a beautiful movie. Okay, let's get going. Electrical lines of force always represent the net field at a point. Very important. So when I say a field line, okay, so when I say there are, let's say, multiple charges, plus, minus, and I'm showing some field line. This is the field line not because of this charge or this charge or this charge or this charge. No, it's because of all these charges. So whenever I show a field line, this is always a net field line. You cannot draw when there are multiple charges. Oh, I will draw a field line for this. Say for example, there are two positive charges. You cannot independently draw field lines like this for this positive charge and this positive charge. No, you're not allowed to do that. You're not allowed to do that. See, you cannot do that. Whatever will happen will be because of both of them. You will always show the net electric field lines. Keep this in mind. Yep. Hi Khushbu Sinha, welcome aboard. Yes, welcome aboard all the new people. There's a 12th standard batch long-term sessions which have just started on Enthuse, which is one of the very few English channels in India on YouTube. So welcome aboard all the new students out here. Okay, next up, two field lines will never intersect each other. Look at this. Field lines are intersecting at this point. This can never ever happen. Remember, the field lines are always the net field lines. So the net field at a point should be always in a unique direction. If you have two field lines intersecting, then you can draw two tangents, E1, E2. You can see that you can draw two tangents, guys. Now if there are two tangents, that means that the field is here and there. You will be confused. Should I go here? Should I go there? Should I go here? Should I go there? No, there is no confusion, guys. Understand, field lines are always unique. So you cannot have that confusion. So they cannot intersect. That's the next property. I hope you guys are writing it down. And do not worry, you are also going to get the PDF of this entire session. All right. Next up, the number of lines. Okay. Yes. The number of lines which will originate or terminate, okay, from a particular point is directly proportional to the magnitude of the charge. Is directly proportional to the magnitude of the charge. This is very important and there are a lot of questions on this also. Yes, more the charge, more the field lines. Now you'll be like, sir, field lines is imaginary. I agree, but while writing it on paper or while drawing it, you will show some 5-6 lines, right? You cannot say, oh, there are infinite field lines. Sorry boss, I'm not going to draw it. You will draw something like 5-6 lines to just show for the heck of it. Now if you show 5-6 lines for this negative charge, and if there is more negative charge over here, then you need to show more field lines, all right, by convention. Understand that. Himanshi, don't worry. Just concentrate on the class. If chat is disturbing you, you can probably close the chat or minimize it and just make the video full screen on your mobile device or probably your desktop or something. All right. So don't worry. Yes. So number of charges are number of field lines are always proportional to the magnitude of the charge. Keep this in mind. Okay. Next up, this is also very important. Okay, Ankit, don't worry, don't attend so many sessions, just attend few channels, Ankit, alright, and stick to it. What's lambda? It's some constant, Munna, it doesn't matter because anyways the number of lines are infinite, right? So you can forget that lambda, it's just proportional. While depicting, just think the number of lines you show as a custom or just like a convention should always be proportional to the charge, just think of it that way. Okay. Obviously, Sunil, what am I doing? I'm teaching everything, right? Right, theory, problems, concepts, application of concepts in the problems, revision, everything is done over here. Yeah. Okay. Next up, field density is proportional to the field value. Understand that. So basically, if the strength of the field is higher, as you go closer, you will see the density of the lines will increase. They become closely packed. If the lines, field lines are close enough to each other, that means the strength is very higher. So very far away, the field is low. As you come close, you will see the field becomes higher, the density is higher. Same thing over here. When you come close, the field becomes higher. Alright, when you go far away, the field becomes less. In fact, if you increase the charge also, like you can see in the simulation, as you add more and more charge, you can think that the field around it will also increase. It will become stronger. So very, very important. The number of lines which are passing through a given section, the density, the closeness decides the strength of the field. Keep this in mind. All right. Okay. Next up, very important property. Yep. More crowd, more strength of corona. That's a good way of putting Vanki. I agree with you. Guys, there were more than 2 lakh cases just yesterday. I mean, like crazy. Yep. Next up, uniform electric field. Uniform field means what? Uniform field means the field does not change its value no matter where you go. Meaning, look at these lines. They are parallel to each other. Do you see that the density of field lines here and the density of field lines here is the same? It is not diverging, converging. The spacing between them is not changing. That means that this field is uniform. The strength of the field here or here or here or here or here is the same. I hope this is clear. Yeah, the crowding is the same. So this is called as uniform electric field. Understand that. By the way, the same concepts are also applicable for magnetic field or even gravitational field. So guys, please do not ask me, sir, can you tell me the properties of gravitational field lines? I'll be like, come here, one tight slap. No, it's the same thing, guys. So field lines will not intersect. Field strength will be decided by the crowding. All right. Again, they will originate at a charge. In that case, it will be a mass and they will end at infinity. So very similar properties. Okay. Next up, non-uniform field, guys. Yes, Bharani, I have heard you and we are coming up with JEE 2022 plan, and tomorrow there is a special lecture from me and that is going to be on what if you do not get IIT or NIT, what are the other top colleges for all the students who are just passing out. So that's going to come up tomorrow. Okay. So anyways, non-uniform field. Non-uniform field means the spacing is not uniform. The spacing is not uniform. Okay. So basically the field strength will be different here, different here. It will be stronger here. It will be weaker here. You can see this same thing. The spacing is not constant. It will be very strong here. It will be very weak here. Again, it is strong here. It is weak here. So the strength is continuously changing. That is called as non-uniform field. Okay. Oh my God, Himanshi, I guess you are the one who told that you are COVID positive or something last lecture. Was it you or was it somebody else? Yep. Okay. Cool. Yes. Let's start with some questions. And here is the first question for all my warriors out there. In the given diagram, describe the nature of the charges placed here and here at this point and this point. Okay, P and Q is not mentioned. Let me tell you what is P and Q. P is here and Q is over here. P is here and Q is over here. What are the charges? What do you guys think? Come on. Yes. Yes, there is kind of curfew, but not like entire India. It's like, I don't know, saying that, yeah, there are 100 people in the class and I have given, I don't know, chocolates to every one of you, and I'm telling you that I call every one of you and I give you one chocolate. I give you one chocolate, and then I'll be like, I have not given the chocolates to the entire class. But the fact is, guys, you know, there is curfew almost in every part of India. but we still claim that there is no curfew throughout the country. Yeah. Is D is the answer? Yep. Captain, field should be curved, right? Depends, monkey. It could be curved, it could not be curved. Yes. Very good, very good, very good. Yes. Okay. So looks like it. Yep. Very good. Minus Q, plus Q. Look at the directions. The field lines are terminating. Look at it. It is terminating. Terminate. Where does it terminate, guys? On a negative charge. And where does it originate? Over here. So this is originate. So that's why it's positive. I hope this is clear. Yep. Very good. Chalo. Let's get going to the next one. Yep. Let's get to the next one. Let's see. This was a very simple question. And here is the next question. Wow, what a beautiful hypnotizing diagram. Consider the electric field lines drawn at the, over here. And there are two charges. There is one positive charge here and another positive charge here. I hope you can see they are equal in magnitude. And you have to rank the locations in the order of the field strength from smallest to largest. A point is here, B point is here, C point is here, D point is here, E point is here. Which point has the lowest? From lowest to largest field. Come on, mark it. No problem, Nicholas, join in. Okay, B, E, A, C, D. Do I provide DPP? So, Bharni, the thing is, we are giving homework at the end of the class, like a question, and we are going to give you Menti quizzes. But if you want DPP, then please join the pro subscription. You will get not just the regular DPPs, the assignments, but also the Tattva module, which is a big, nice collection of problems, theory, derivations, definitions, important formulas, easy, hard, medium level problems with previous year questions. That is Vedantu's material, which is called as Tattva, and you will get a hard copy plus a soft copy when you are in the pro subscription. Plus you get the regular DPPs. Okay, chalo, let's see. Yep, super tasty. Wow, monkey, looks like you have started licking it already. And the correct answer is DAECB. Who said it? Let's see. DAECB. DAECB. Did anybody say that? DAECB. Oh my god. Now people are typing. Okay, Shivangi and Kirti Aran have said it. Okay, now maybe Anish, you have seen this or what? Okay, so Anish also, maybe I'll give it to him. Yeah. Okay. Okay. Look at that. Look at that. Okay, looks like now people are writing it. So guys, D, look at it. There is no field here. Bichara. Do you see? Crowding. Is there any crowd here? Just look at the crowd, na? Will there be crowd here? No, right? So D is the least. Then look at A, very far. A is very far. You can see the crowding is not that great. DA. Then you are coming little bit closer. Not as close as B or C. Then you are coming little bit closer. So DAE. And then you can see at C, the field lines have got little bit more closer. And at B, you are extremely close to the charge. So that's why B. Okay, I hope that is clear. Maybe when you have this on your paper or in front of you, probably you can see the field lines more closely and you can see this for yourself, that the crowding is the least at D, and then you have it at A, and then at E, and then at C, and then at B. B is the closest. C, you can see it's decent. E is still okay, and then A is little bit less, and then obviously you have D. Okay, so that's the answer. Here is the next question coming up. Let's see how many of you can give the answer really quick. Waiting for it. Waiting for it. The number of field lines from a charge Q are 10. Then the number of lines from 2Q charges. This is the easiest question. Let's see who can answer this really quick. Really quick. Okay. Really quick. Waiting. Let's see. Shadow, Kirti Aran, Monkey, Munna, Bhai. Please add Ayurveda questions in Pathfinder series. In fact, Munna Bhai, I had indirectly included a few questions in the in Killer 5 series. So understand, Pathfinder is a basic course because you want to understand the concepts. Slowly I can scale you up. Immediately if I give you a lot of problems, you will be like, what the hell? And you should never solve Irodo when you're learning. You should solve Irodo once you have learned the concept. Okay. Okay, no problem, Yalini. Join in. Yes, Kiritu is always quick.Maybe he has a very good internet connection. Maybe you should tell it to us which internet connection you have and what's your speed. So guys, yes, it is 20. Guys, this is like, yaar, simple Marwadi question, yaar. Matlab, for one biscuit, it is 10 rupees. For 2 biscuits, how many rupees? Unitary method. You know, I call unitary method as Banya method or Marwadi method because, you know, even a shopkeeper will know that. For 5 packs, this many rupees. For 10 packs, how many? That's unitary method, right? So that's it. Yes. Yep. Let's get going to the next one. All right. Cool. Let's get going to the next one. And a few electric lines of force for a system of 2 charges, Q1 and Q2, fixed at 2 different points on the x-axis are shown. Very beautiful question. Those lines suggest that magnitude, not the sign, okay, of 1 is more than 2, magnitude of 1 is less than that of 2. At some distance to the left of Q1, the field is 0 or none of the above. Okay, come on. No, Nicholas, I'm not ignoring you. I'm seeing all the chats. Don't worry. Sometimes I get to read something or sometimes I reply to someone. Does not mean that I am ignoring any of you warriors. Don't worry. All right. Cool. Chill. All right. Exactly, mate. Oh my God. Looks like Neha has already learned the Australian lingo and they call mate. It's very difficult to get it in that accent. How mate? Okay, I do not get it. I will practice it and I will try and do that. Okay, cool. Thank you, Bharani, and thank you, Vikram, for all the fire. Please don't put me on fire. Okay, I'm already burning with this heat. I don't want more fire. I want some ice. Okay, cool. Okay, so guys, what you need to do, check the number of field lines. Check the number of field lines. Here more lines are coming. Can you count? Everybody knows how to count? Till how much do you know how to count? 10, 5, 4, 100, 200, 1 lakh. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 lines are coming. Oh my God. So cool. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines are there. So less charge here, more charge here. Obviously, guys, I hope you can distinguish between them. Else, this diagram also acts like an eye test. Yes, this diagram is also used as an eye test, and that also can suggest that probably you have some power. Alright, so if you can count, yes, you can see more lines here, more charge here, less charge here. Hence, option A is correct. That's it, option A. Done. Yep. Thank you, Himanshi and Vikram, for all the ice. Thank you, Eleni, for the ice cream too and the juices too. Thank you. Hi, Jaideep. Welcome. Cool. Yes. Let's get going to the next one. Yep. Now, my God, every time, why do we have this, guys? Every time one guy is always there who will tell, sir, please teach in Hindi. Guys, when we had a Hindi channel, then you guys said, please teach in English. Now we launched an English channel for you. Then you guys say, sir, please teach in Hindi. Guys, there are 2 different channels. We have Hindi channel as well and we have an English channel as well. So guys, you can choose your medium on YouTube at Vedantu itself. Okay, so let's get going to the next one. Okay, beautiful diagrams out here. 3 positive charges, equal value, 2q, 2q, 2q at the vertices of an equilateral triangle. At equilateral triangle, come on. Then guys, what is the field line going to look like? What is the field line going to look like? Come on, think about it. What is the field line going to look like? Come on, think. See, I don't know. Obviously, Anil, don't worry, don't get scared. I'm going to be teaching in English only. Don't worry. Okay, cool. All right. Arey Chandrakant, chill. All the teachers are good. All the teachers everywhere at Vedantu and even on YouTube, all the teachers are good. Everybody is doing a good job. It takes a lot of effort, lot of guts, lot of preparation and lot of knowledge and lot of experience to come over here in front of the camera, in front of the whole world to teach. All right, so all the teachers are doing a fabulous job, let me tell you that. Yes. Okay, so guys, the answer is, it's not a widget spinner. The answer is this. The answer is C. Yep, it's not A or D. I don't know why you marked this. Why you marked this? This looks like a widget spinner to me. Yep. So guys, the answer is this. See, the field lines will go away from each other. What the hell is this? What is this circle and there is a balloon like thing? Guys, how can the field line intersect itself? What the hell is happening out here? I mean, and what is this? How can field lines originate and terminate on positive charges? So A is ruled out. Here there is a circle. What nonsense. And this is correct. None of the lines are intersecting. Field lines start from the positive charges and they just go away. Yeah. And this, what the hell? This is like fidget spinner. Doesn't make sense. How can the field lines be circular? Field lines have to start somewhere and end somewhere. They cannot have no start, no end. Nope. That's not the possibility. All right. Yes. Direction zarurat nahi hai Manshi. No need of direction. You just need to check how the field lines are there. In fact, doesn't matter even if it was negative charge or even if it was positive charge, the diagram would look same. Only the arrow marks will change. That's the trick. So if you replace positive with negative, negatives with positive, what will be the change in the diagram? Only the arrow marks, but the curvature, the curves, the shape, the size will all remain the same. Yep, I hope this is clear. No Chandrakant Patil is not possible because they are starting and ending here. All of them are same charges. Do you see that? Equal. So they can start, but they cannot end on the same charge because the sign is the same. They can only end on the opposite charge, -1. I hope now it is clear. Yep. All right. Let's get going to the next one. Consider the 4 patterns out here. Consider the 4 patterns out here. Assuming there is no charge in this region, in this region, in this region, in this region. Which of the pattern is a possibility of electric field? Come on, think about it. Which of the following is a possibility? Only we need to see the strength. Yes, you need to see the strength, Nicholas. You also need to check whether they are originating, terminating, or if they are forming closed loops and all of that. Yes, you need to see all of that. All the properties, in fact. Okay, let's see. Yep, due to repulsion. No, only one option is correct. Only one option is correct. No, it's not a multiple choice criterion. Noops. Oh my God, Vikram, please don't put fire, man. I'm already getting heated up out here. Okay. Oh my God, yeah, that's a good thing. We always call teachers as sir and ma'am, but the crowd here calls me captain, and I love the name all you warriors, all you minions have given me. Captain. I love that. Captain Shreyas Sir, Captain Shreyas Sir, I love it. Dinner, I had chatpata. I just had biryani just some time back. Okay, the correct answer is actually, oops, where is that? Yeah, B. Now, why is it B? I'll tell you why. Look over here. In diagram A, they are terminating over here. They are terminating. Now, if they are terminating, what is present over there? A negative charge. But what is the question demanding? Thank you, Bernie, for all the love. Yes. What is the question demanding? Consider the patterns assuming there are no charges. There is no charge over there. There is no charge. But in this case, there is actually a negative charge. So hence this option gets ruled out. This option gets ruled out. Now in B, you can see that the field lines are coming from somewhere outside and they are going somewhere outside the diagram. So there is no charge in this part. Check this part. Is there any charge? Nope, right? So there is no charge in this part. Over here, do you see the field lines are actually starting from here? Do you see these are the points where it originates? It originates, and when it originates, what is there? Positive charge. So actually positive charges are present here. In fact, they are also terminating in this point. You can see that. So hence that is wrong. It is wrong. Option C is wrong. And option D is obviously wrong. In this part, you can see there are points where it terminates and there are points where it originates. So that means there will be some charges present over here. So only option B is correct. Yep. Come on guys, concentrate. Please don't concentrate on RCB and IPL. That's not our focus. Our focus is electrostatics. Yep. And guys, this is how micro courses look like. So in fact, I have conducted micro courses on electrostatics, H.C. Verma book solution, Irido problems, previous year question, numerical question. So many micro courses are there, not just by me, but also Shimon sir, Wazim sir, and so many other teachers. And this is how it looks like. Now you might see some prices out here, 49 rupees, 49 rupees, 19 rupees. It's less, but still it's something. It's like, oh, I want to watch a movie on ray optics. I need to go and pay in the theater. Oh, I want to go and watch a movie on wave optics. Oh, I need to pay 29 rupees in the theater. But what if I tell you, well, there is Netflix, there is Amazon Prime, and a lot of subscriptions where you just pay the subscription fee and you can watch all these movies for free. You can watch any of them any number of times at the comfort of your home. And that's what micro courses are. So guys, do not forget to check out the pro subscription, because if you enroll in pro subscription, all these micro courses, this is just a sample. There are thousands of it by almost all the teachers, again in English as well as Hindi, where you can join out. All right. Yep. So we Enthuse FC South India. Can I also include JEE Mains previous year question? Oh yes, I'm already including. Some of these questions are actually PYQ. Maybe I did not write it over there. Does not mean it is not a PYQ. It is already a PYQ. Okay. Many of these questions are PYQ questions only. And yes, please don't spam V Enthuse. I can read everything. Okay. Let's get going. Yes. Yes. Please don't spam. Okay. Very good. A lot of you have understood. Interesting. Let's get moving to the next part, which is equipotential. Equipotential. Now, what is the meaning of equipotential? Equipotential, like the name suggests, equal potentials, same potentials. Same potentials. All those points which have same value of potential is called as an equipotential line or an equipotential surface. So let's say, for example, there are some charges. Let's say there is a positive charge, for example. Now, think about it and tell that where will you see all those points with the same potential? See, for example, I stand here. Because of this charge, I will get some potential. K, Q by R. Correct? That's the value of potential. All those points with the same potential will be on a circle with the same radius R or same distance R. They will be on a circle. Kirtier and Gauss's law is a separate chapter. We'll be doing it later on after the Menti. Okay. So they are all on a circle. Also, there is another circle of same potentials, but they have a different value of potential. If I tell you this is 10 volts, maybe this could be, I don't know, maybe 8 volts or something. This is 8 volts. So all these points have 8 volts of potential. All these points have 10 volts of potential. Between these 2 points, there is a potential difference. Yes, there is a potential difference. So that is the meaning of equipotential line or equipotential surface. Strictly speaking, this point charge will create an equipotential surface, because you can go here, you can go here, you can go here, you can go there, you can go here, you can go here. It's all the points on this spherical surface will have the same potential, but on a 2D diagram, I can call it as an equipotential line. Yes. No, Himanshi, tomorrow is not practice or Menti session. The Menti session is next week. Tomorrow we are going to have which college to choose in case you do not get IIT or NIT. What are the other options? It's not like IITs and NITs are only the end game. There are a lot of other choices. Saturday is killer 5 session, and Monday I'll be having Monday or Tuesday I'll let you know. We'll be having Menti quizzes. Okay, I hope you have written it down. Okay, so that's why I'm going to give you enough time so that you can prepare for the Menti quiz, and I will keep a lot of questions. So guys, it's going to be like rapid fire also. Yep. So Bharni, don't worry, even if you are a NEET aspirant, you can still attend all the classes, because physics is Physics. Yep. Now, equipotential surface may be a surface of a body or a surface in space, anything. Okay. So for example, think about it. Yes, let's see. This is an example. The surface of a charged conductor is equipotential. So let's say there is a conductor. I give it some charge. What will the charges do? They will not like each other. They will be like, okay, let me all move away. It's like putting 100 people who do not like each other in a room. The room shape is like this. All these 100 people hate each other. They'll all be in the corners of that room. So you will see the charges will go on the surface. Something like this. Now, remember all the points. This is a charged conductor. This was a charged conductor. Yes, this is a charged conductor. So basically understand all these points are at the same potential. Yes, this is at same potential. Yep. This is an equipotential surface. Understand that. Yep. There is no potential difference. There is no potential difference. If you stay here or stay here or stay here, there is no change in potential. You'll be like, sir, why? Why is there no change in potential? Guys, simple, no? If there is a potential difference, assume, then what will happen? Current will flow. Current will flow. And what is the name of the chapter, guys? The name of the chapter is Electrostatics. Electro, charge, statics, stationary charges. So you cannot have flowing current in this. So that's why you will not have any potential difference in that conductor. I hope that's clear. Yes. Thank you, Mohit Kumar. Glad you said that. So, understand equipotential lines or surfaces could be anything. It could be actually on a body. It could be imaginary, just like I showed it for a point charge. Very good, Barney, making notes. Yes, so that is what equipotential lines are. And let me also show you some more things. All right, there we go. Look at this. I just showed you for a point charge. Here it is. The field lines are like this. And look at the red dotted lines. Those are equipotential surfaces. Now, my question to you is, if you have seen this diagram now, can you see some relation between field lines and equipotential lines? Can you see the relation between field lines and equipotential lines? Think about it. Is there some obvious relation, obvious similarity, or some kind of resemblance, or some kind of property that you can figure out from this diagram? Yep, somebody already said it. They're always concentric. No. See, only for a point charge it is concentric, but for something else it could be something else, right? So it need not be concentric. Somebody said it. Yes, Munna Bhai MBPS said it, and Kirti Haran also said it. Yes, they are perpendicular to each other. Correcto. Excelente. Very good. Amazing go. So guys, remember this first property. Field line. Alright, field lines are always perpendicular to equipotential lines or surfaces. This is the first thing that you noticed from this diagram. Okay, very good. Okay. Now, next thing, check the direction. Guys, before doing that, if I ask you the potential at this point, example, or let me write it here, example, the potential at this point, let's say is, I don't know, 10 volts, example. The potential at this point may be 8 volts. The potential at this point may be 6 volts. Can you now think of something else? Wow, Anjaneyulu. My God, my tongue just got twisted. Anjaneyulu Linganagari. Thank you so much. I'm so sorry if I pronounced your name wrong. Yep, it was a tongue twister for me. Okay. So do you see something else? It is decreasing. Why is it decreasing, Somik? Guys, remember potential formula was KQ by R. The farther you go, the lesser the value of potential. That's why it is decreasing. Okay, Shamla, hold on. JEE 2023 course is coming. So guys, the resemblance or the property that you should see over here is that if you have high potential, all right, and there is somewhere where there is low potential, all right, low potential, then the field lines will always travel from high potential to low potential. Look at that, high to low, high to low. Always field lines will go from high to low. Yep, that's what you can see. I hope this is clear. Is this clear? So don't say inversely proportional to radius or distance decreases. See, we have to find a generic property. See, the field lines might not be always a radial and potential lines might not always be circular. This is only for a point charge. But in general, the property goes that the field lines will always travel from high potential to the low potential. Keep this in mind. Yep. Yes. Now, yes, tech redentum, we are coming to that rate of change also. Yes, Mohit Kumar, please ask. Definitely. Another important thing is that this potential will not change with the same amount as you go far away. The potential will not change by the same amount. Yeah, believe me. As you go far away, the field will become weak. The field will become weak. And as you go close, the field becomes stronger. So wherever the field is strong, the potential will decrease rapidly. It will change, not decrease, it could decrease or increase also. The changes are rapid, and wherever the field is weak, the changes are slower. So wherever the field is strong, all right, the changes in the potential are also faster. So understand the change in potential, all right, the change in potential depends, all right, it depends, or I can say it is dependent on the field strength. The field strength. In fact, I'm going to give you a formula also for that. It depends on the field strength. Is that understood? Very good. Got it? Got it? Excellent. So these are all the important properties. Please write it down. We are going to come to that. Yes, Munna bhai. Very good. Already said that. Okay. So write it down. I'm giving you some time. Okay. Okay. By the way, my sweating business is going to end very soon. And guess why? My sweating business is going to end soon. I'm just, yeah. So finally, I went out. Hello, techno gamers. Yes, Vedantu student. Yes, AC, DC, AC is coming. AC is coming. Yes, I just went and I was like, okay, to hell with Bangalore. I know you are not going to keep me cool. I even did a rain dance, you know. I was just doing a rain dance just 2-3 days back outside. I'm like, please, barso re mega mega, barso re mega mega. But no use, guys. I mean, like, no rain also. Yep, no rain. So then I was like, okay. So I did rain dance. I sang the song barso re mega mega. And then I was like, okay, ठीक है. So I need to order an AC. So I just ordered an AC, please. Yeah, and it is coming soon. Yeah. Cool. Let's get going to the next one. Do we call field strength as intensity, density too? No. Field strength itself is intensity, monkey D. Luffy. Shower, Himanshi, you seriously don't want me to be under the shower while teaching, alright? So you really don't want me to be in the shower, and I'm taking a YouTube class, though it will be very funny and hilarious. Alright, okay. Let's get going. Okay, so next up, if you have uniform field, okay, if you have uniform field lines going like this, then if you have uniform field like this, then the equipotential lines are like planes. Look at that, planar surfaces. So if field lines are going there, remember potential lines are always perpendicular to the field lines. So look at that, they are all perpendicular, ऐसे surfaces, one after the other, layers. So you can see that. Guys, if I ask you, all right, this is the direction of the field line from left to right. The direction of the field line is from left to right. Think about it. Think about it. Which of those two surfaces will be at higher potential? Left surface or right surface? Left surface or right surface? Which is at higher potential? Come on, think about it. Yes, tech redentum, I am on Quora. Left or right? Left or right? Which is at higher potential? Come on, look at the obvious thing. Yes, left surface, because field always goes from high potential to lower potential. All right, look at the direction. Yes, high to low potential. This is another example. Another example of equipotential surfaces. Look at that. What are these? These are dipoles. These are dipoles. Equal positive, equal negative. Earlier we have seen the field lines. Now you just draw the perpendiculars. Do you see two big eyes of a fly or a frog or some insect? It looks like an insect. Oh, it looks like a spider to me with its legs out here and the two antennas. So those two antennas and those legs are the field lines, and these are the eyes. All right, those are the equipotential lines. I hope you can see that. Yep, and okay, cool. Great. So that is the equipotential lines. Okay, another example. Two positive charges. The field lines will not intersect, they will just go away like that. What is this point? Can you tell me, guys? This is a special point over here in between these two charges. What is that special point? Oh my god, modified corona crab. Yep. My god, Griffiths for mains, Vikram, it's too much. Not needed. It's like practicing integration for second standard exam. Yes, no, it's not zero potential. In fact, it is zero field. It is called as a neutral point, null point. Very good, Krishna Mohan. Excellente. So voltmeter works on potential difference, Nandu. Yep. So at this point, in fact, the potential is not zero. The potential due to this, both will add and you will not have zero potential. But the fields are opposite. In fact, the field lines are turning away. They are shying away from this point. So that's why the field is zero. Yep. I hope this is clear. Okay. So now let me show you one more interesting thing, and then you're going to love this more. Are you ready? Let's do this. We got a positive charge. Look at this. Look at this positive charge, guys. Okay, let me just get rid of the voltages. These arrow marks, what do these arrow marks show? Field. These arrow marks show field, guys. And look at that. As you go far away, the strength of the field is decreasing. The strength of the field is decreasing. So you can see that very clearly. The strength of the field is decreasing. Now, let's add two positive charges and see how does it look like. There you go. This is how the two positive charges ka field lines look like. And then when we have three positive charges, remember there was a question on this just some time back. Three positive charges. How does the field lines look like? So that you can see the field lines are moving away from this. This is going away like this. This is going away like that. This is coming like this. This is coming like this. All right. But if you replace this positive charge with a negative charge, they will end up coming over there. They will end up. Yep. Yes. This is how it going to look like. Yep. And then you can also have a look at the potentials. The red zones are with negative potential. The blue zones are with positive potential. Or sorry, my bad. The red zones are with positive potential. The blue zones are with negative potential. So you can see that the potential keeps changing. So as you move these charges, you can see that this is a region with high positive potential. This is a region with negative potential. Somewhere in the black zone, it's almost zero potential. Yes, that's how it looks like. Okay, I hope now things are more clear. Yep, you can use and play with this particular simulation as much as you want. You can add more charges and you can have fun and you can see how they interact with each other. All right, now the last point that I need to mention over here is E is minus dV by dr. Oh sure, no problem, Catch-Sharon. Definitely do that. Thank you. Okay, Shivangi, I'm explaining about an extreme cyclone. Yes, looks like cyclone, that weather reports. Yep. Okay, so guys. Oh my god. Okay, so this is a very important relationship. If you remember, force was minus du by dr. This was a relationship which I gave you. This was a very important relationship. Force was minus du by dr. Yep. Krishna Mohan, how many times to tell you Gauss law is next week, man? This is electrostatics, last lecture. I'm going to come up with Gauss law. Hold on, I'm not running away. I'm not packing my bags and learning. Okay, hold on, chill. Okay, so if you divide force with charge, what will you get? Field, right? And if you divide energy with charge, what will you get? Potential, right? So this relationship exactly gives us this. Now it depends. Some people teach it as a part of electrostatics. I teach it separately. Okay, don't worry. Okay. So this is exactly this relationship. This is the father of this equation. This is a son. Okay, this is a bacha. All right, this is a father. Okay, think of it that way. Now, how do you use this relationship? For example, I'll just give you a question. Say potential at a point is given by 5x square, and the question is find the field. The question is find the field. All you need to do is, okay, you need to find the field, right? What is field? It is minus dV by, now in this case it is a function of x, right? So instead of r, just put x. So instead of r, the position, you put x. That's it. So guys, guess what is going to happen? Minus d by dx of 5x square. So this is going to be minus 5 is going to come outside. X square's derivative is going to be 2x. 2 5s are 10, so it is going to be minus 10x. As simple as that. Minus 10x, that's the answer. Correct. So this electric field is along the x-axis. I hope this is clear. Similarly, let's do another question. Example. The potential is given by, let's say the potential is given by 7y minus or plus some 2. This is the potential. The question is find the field. The question is find the field. All you need to do is field will be, okay, so field, guys, what is the field? Field is minus dV by dr, but here v is a function of y, right? So just put y over here. As simple as that. So it will be minus derivative of this. Derivative of this is going to be 7 plus 0. So it is going to be minus 7, guys. That is the answer. As simple as that. Okay, I hope this is clear. Okay, bye Nicholas. Bye. Take care. So what, easy? Yes, Vikram, it is easy. Okay. Very good, minions. Very good, my warriors. Now let's do some questions. If the field is along the x-axis, then the equipotential surfaces are parallel to, come on, let's see. Come on. Think. If the field is along the x-axis, then the equipotential surfaces are parallel to which plane? XY plane, XZ plane, YZ plane. That O stands for origin. That O over here stands for origin. Come on, guys. Which of the following? If the field lines are along the x-axis, isn't it obvious? Yep, it's answer C. Correct. Because this is X, this is Y, this is Z. If the field is in this direction, guys, the potential surfaces are going to be like that, parallel to the YZ plane. And that's why this is the answer. You can see that. Very simple, very good. Let's get moving to the next one coming up on your screen. There we go. Okay. Hocha. All right. Very good, Nicholas. Okay. Don't type so many times, Nicholas. I can read once. Don't spam. Okay. Find the potential difference between A and B. Let's do this. Okay. Let's see how to do this. Find the potential difference between A and B. Now, this is not so straightforward. I remind myself of that equation. Field is minus dV by dr. Okay, now let's talk only in terms of magnitude, and instead of derivative, because this is uniform field, I hope you can see that this is uniform field because the field lines are parallel. That's one thing for sure. So can I say the field magnitude wise, just forget everything else, all right, the field, all right, the magnitude wise is delta V by delta R. Field magnitude is delta V by delta R. Change in potential by delta R. Manswini, Somnathi and others, the bridge course for 10th to 11th standard students is starting next week only. Next week. Okay, this week the schedule was already planned and the schedule was already tight. So sorry guys, but we are coming up with the bridge course next week itself. Okay, please Bear with us. We have planning, we have not forgotten you, and we are ready to welcome you guys. Don't worry. Okay. Now the magnitude of the field is E0. You can see that from here. It's E0. Delta V, I don't know. Delta R is this distance. It's this distance, guys. Now, how much is this distance? Think about it. Use those coordinates. How? Draw a right angle triangle, and the hypotenuse is nothing but delta R. Now, can you guess what is the height and the base of the triangle? Can you guess? Already some people have already written it. Very good. This is 1, this is 5, so obviously base is 4, right? This point has x coordinate as 1, this point has x coordinate as 5. The difference will be how much? 4. Same thing applies for height. So what will be delta R? Use Pythagoras. 4 square plus 4 square root. So what will be delta R? That is nothing but 4 root 2. So just substitute it over here. 4 root 2, guys. So hence, what is delta V? It is E0 4 root 2. That's the answer. Interesting. Interesting. Understood, everyone? Beautiful. This is how you get the answer. So you might get some numerical based questions on E is delta V by delta R. Wherever potential changes, wherever the potential changes really fast, field is strong. Wherever the potential changes slowly, field is weak. This is what I was just telling you about. Okay, so that's the answer. And the last question coming up on your screen, and here it is. The figure shows several potential lines, equipotential lines. Compare the points A and B. All right, which of the following statement is correct? This is the last question for you guys. Come on, guys, let's do this. Okay, Munna bhai, hold on. MBBS is not done in 1 year. MBBS is done in 5 years. Same way, Gauss law, electrostatics, capacitance is done in few weeks, not in 1 week. Hold on, we are going to cover it all, and you will be able to do it. Hello, Vijay Kumar. Thank you for calling me Thalaiva. It means a lot. Hello, Uday Thakkar. Welcome aboard. Tech Redentum. I think by the time you come back in 20 minutes, the lecture will be over. Okay. Come on, come on, come on, come on, come on. Last one, last one, last one, last one. Come on, come on, come on. These are the potential lines. What do you guys think about it? Okay. Some of you are saying B. Some of you are saying something else. I don't know. Come on, come on, come on, come on, everyone. Hello, Amra. Come on, guys. All those people who are joining in late or joining in new. So guys, first of all, welcome to Enthuse, the only exclusive English channel in India on YouTube. And we are in the Pathfinder series, which is 11th through 12th students who are, going to write the exam next year. Yep, in JEE 2022. So this is a series exactly for that, for them. And yeah, welcome aboard. And do not forget to hit the subscribe button. And guys, if you are already enjoying this session, I hope you have liked the video. In case you haven't liked the video yet, please do that now. Yes, come on, I want the likes to increase. And if you are a new user, do not forget to hit the subscribe button as well. Come on, do that right away. Yes, the correct answer is actually A. I'll tell you why it is A. The field is greater in magnitude at point A. I'll tell you why. Look at these lines. The spacing. Look at the spacing between them. The spacing between them. Over here, the spacing is very, very less. All right. The potential, all right, the potential changes rapidly. It changes rapidly. Now, whenever potential changes rapidly, what happens? The field, all right, the field is strong, correct? The field is very, very strong, and that's what will happen at this point. The field is greater at A, and where is the field going to be? The field always goes from high to low. From high to low. Now check this out. If you see the lines, this is low potential, this is low potential, and this one is basically high potential. I don't know whether you can see that very clearly, but yes, it is. This is 5-volt line. That is 25-volt line. So high to low. So field will be directed towards the left side. Yep. I hope this is clear now. Yep. Yes. Is that clear now? Yep. Yep. Is that clear? Very good. And guys, if you want to know more about me and you want to follow me on my social media account, that's over here, Shreyas_Vedantu. Yep. And this is a homework question. Do not forget to leave a comment below on the video. The answer to this question will also be uploaded in the PDF of which will be uploaded in the Telegram group as well. Yes. So do not forget to leave a comment of what you think the answer for this question is. This is your homework question. Now, let me also tell you guys about the Vedantu Pro subscription, because I know some of you are interested to learn under me and teachers like me, like Shimon sir, Wasim sir, and all the other great teachers out here at Vedantu. So first of all, let me show you all the results that we produced this year. Yeah, come on, look at that. So our JEE Main toppers, and look at the number of people above 99 percentile, 307 students. Not just that, 1 in every 2 students in the February and March attempt is almost eligible for writing the JEE Advanced. 1 in 2 Vedantu students is almost eligible to write JEE Advanced. 100 percentile, there are 11 students in physics, 6 students in maths, 2 students in chemistry. And all this is because of year-long hard work, dedication and support from the Vedantu platform. So guys, you know, we not only give you the regular classes where you have 5,000 plus hours of live learning, but also your regular test series, assignments, what you call it as DPPs, you will get it after every class, and you have to submit, you get grades, you get, you know, your feedback, you will get to know how you are progressing. Yes, so that is basically continuous area. You will get reviews on how you can improve upon yourself. Obviously, needless to say, the best teachers in the country. Also, an option to learn in Hindi as well as English. I hardly know of any institute which does this. And lots of micro courses, crash courses till the end, guys. We are going to be there till the end, and all these teachers are dedicated to teach you. We are all full-time employees. Please understand that. It's not like I teach at Vedantu and I teach somewhere else and then I have my private coaching. No, we are all dedicated teachers, all from reputed colleges out here, with only one goal: to get amazing results, to improve your performance. So guys, if you are really enthused about this, do not forget to check out the description box, because the Vedantu Pro subscription, usually which costs 48,600 rupees, has 10% off only when you use this coupon code SHHPRO. Alright, try using this coupon code, you will get the course for 43,739. But if you want to pay this amount in installments, that is also available. So you can pay this amount over a period of 12 months. So you can pay probably 3,000-4,000 rupees per month. That's like just paying your fees for tuition, and you, the burden reduces even more. So there is an option in the payment. So do not forget to check that out. All the details are mentioned in the link which is there in the description box below. So do check that out. And I hope you have enjoyed this session. Do not forget to subscribe and like this video. Bye bye guys. See you tomorrow. Take care. Yes, I'll be seeing you guys at 9 o'clock sharp. So the Menti quiz is going to be next week. All right, not tomorrow. Saturday, killer 5 questions for JEE Advanced 2021. All right. Yep. Thank you, Monkey Little, for loving the session. Yes, I'm decently active on Quora. Glad cat you could make it till the end. And by the way, I have some good news. Next week onwards, my lectures are going to be back at 7 o'clock. Yes, my lectures are going to be back at 7 o'clock, 7 p.m. in the evening. Yes, that's what we are going to do. Yep. Oh well, Tech Reddington, you are so techy, so I'm pretty sure you'll be able to find me over there. Yes, Menti quiz will be on Tuesday or something. Yes, we are going to be back at 7 o'clock, and only for this week, we are at 9 o'clock. Okay. Yep. Bye-bye, guys. Take care. Bye-bye. This was Shreyas here, signing off.